Now previously we've discussed the perfect squares and the perfect squares rule, where we said if we had ax plus b all squared, that was equivalent to the first term squared, so this ax squared, plus two lots of abx, and then plus b squared. Now the purpose of this video is to factorize by what's known as completing the square. And we're going to focus on completing the square where our a value is equal to 1. So what does that mean for this rule? Well, if a is 1, what we can now say is we've got x plus b all squared is equal to, well, 1 squared is going to be 1, so it'll just be x squared. And 2 times 1 is just going to be 2, so it'll be 2bx. And then add my b squared. So what I'm essentially trying to do in the problems that I'm looking at now is to determine what this b value here has got to be. So let's take a look at a problem now to explore this. What if I had, let's say, x squared plus 6x subtract 2. So what I'm really looking at here is I'm looking at this value here. Now to complete the perfect square, I would need to square root this value, multiply it by 2, and it should equal 6. Now clearly, we're not going to be able to do that with negative 2. So we need to invent this b value into this problem somehow without changing the value of the expression. So how do we do that? Well, we know that this b value here is half of this 6 value here. So we need to divide this middle term by 2 to find our b value. So our b is equal to 6 divided by 2, which is equal to 3. And what I need to do is I need to add 3 squared to this problem here. So let's rewrite this. This is the equivalent of x squared plus 6x, but now I want to add b squared. So let's add 3 squared. And I tend to put this in brackets because it can matter when it's a negative value. So then I need to subtract my 2, as my problem said. But what I've now done is I've changed the value of this problem because I've added 3 squared, or added 9 to the problem. So what I need to do to get it back to the original value is to subtract 3 squared, or subtract 9. So let's subtract my 3 squared. And now I've got an equivalent expression to what I had to begin with. And I can now also apply my factorizing by completing the square. So my b value is equal to 3. So when I factorize this, this is going to be x, add my b value, so add my 3, all squared. And that factorizes this part just here. So then I've still got subtract 2, subtract 3 squared at the end. Now 3 squared is 9. So negative 2 subtract 9 will be subtract 11. And what I've now done here is I've factorized this by completing the square. And completing the square has plenty of uses, but we're going to explore those uses later on. For now, let's check that we've factorized this correctly, as we always do. Now when I'm checking here, what I'm going to do is I'm just going to apply the perfect square rule here. So that'll be my first term squared, which will be x squared. Then it'll be 3 times my x, so 3x, but 2 of them, so plus 6x. And then 3 times 3, which will be 9. And then that'll subtract 11. So now I simplify by collecting like terms. So that'll be x squared. There's no other x's, so just plus 6x, and then positive 9, take 11 will be negative 2. So I've got x squared plus 6x, take 2, which means I've factorized this correctly without changing the value of the expression. But before we finish, let's explore one more problem. Let's say I had x squared, subtract 5x, and add 10. Let's have a look at what happens here. Well, my first step is to identify what my b value would be here. And to do that, I halve my middle term here. So my b value is going to be equivalent to negative 5 on 2, which doesn't simplify any further nicely. So let's just leave it as -5 on 2. And what I do with that value is I add it to the problem, but add it squared obviously, and I subtract it squared to keep the value the same. So this is going to be x squared, then I'm adding my, subtracting my 5x, looking at that problem, and then I need to add my -5 on 2, but that's got to be squared as per this. Then I need to add my 10. And then to keep this equivalent, I need to subtract my -5 on 2 squared. So let's subtract my -5 on 2 squared. And this is where you see why including brackets here is really important. So let's now factorize this. So because I know what my b value is, I can put it straight into my brackets. So this part of my problem here is going to factorize into my x plus my b value. Now my b is negative, so I'm actually going to change that to be subtract 5 over 2, and that's going to be all squared. And I'm going to be adding my 10, and let's subtract this squared. So to square this, a negative times a negative would be positive, so I'm not going to have another negative here. 5 times 5 will be 25, and 2 times 2 will be 4. So we'll be subtracting 25 on 4, which is 6 1/4. So when I think about this, let's just simplify this. So I've got x, take 5 on 2, squared. And then I've got 10, take 6 1/4, which is 3 3/4, which is 15 on 4. So what I've now done here is I've factorized this statement here by completing the square. But let's check just to make sure that I've got this all factorized correctly. I'm going to do my check over here. So let's just expand this out, and I'll do it a little bit longer than I usually do. So x times x will be x squared. Then it'll be this term times this term. So -5 on 2 times x will be take 5 on 2x. I need to do it again. So -5 on 2 times x will be take 5 on 2x. You could rewrite this and use FOIL. I'm just doing that in my head. And then -5 on 2 times -5 on 2, or negative times negative will be a positive. Then that'll be 5 on 2 squared, which I'll worry about in a moment. And then add 15 on 4 at the end. So let's collect the like terms. So what I've got here, I've got x squared, then I've got -5 on 2x, take 5 on 2x. So this will be common denominators, which is nice. So it'll be take 10 on 2x. And then let's just expand this out. So 5 squared is 25, 2 squared is 4, so we add 25 on 4, and then add 15 on 4. So now let's continue simplifying. So 10 divided by 2 will be 5. So this will be x squared, take 5x. And then all common denominators again, so that works nicely for us. So this will be add 25 plus 15 is 40 on 4. And then one last step, let's go x squared, take 5x. And then 40 divided by 4 is 10. And what I've got here is x squared, take 5x plus 10. So this is equivalent to this, but in factorized form. So in essence, to factorize by completing the square, we need to find what the b value is by halving that middle term, and then we need to add that b value squared and subtract that b value squared to that expression to make sure that we haven't changed the value of the expression. From there, we simply use our substitution to factorize that section and simplify this side of the expression.